Hi, and welcome to today's webinar, The Future of Distribution Grids. I'm Claire Fulkvane, editor of Smart Energy International, and your moderator for today's discussion, which is brought to you by Siemens. During today's webinar, you'll learn how Siemens Solutions can help distribution system operators prepare distribution grids for the challenges of the transition to a new energy mix. Medium and low voltage power grids need to handle changes due to the increased integration of distributed in-feed from renewable energy, fluctuating peak times, aging infrastructure, and growing electromobility in private transportation. While more and more of the necessary connection capacity can be provided through grid expansion, the effects of changing energy flow direction, load fluctuations, and voltage range compliance can only be managed with intelligent solutions. The future distribution substation combined with intelligent automation is the ultimate solution concept to address those challenges. Now, our experts for today are Bernd Schupffeling, who's a senior key expert and PLM for MV switchgear from Siemens, Oliver Schroedel, senior KE and SLM for distribution grid solutions and applications, also from Siemens, and Rodrigo Braga, a consultant for distribution grid solutions and applications, again from Siemens. Gentlemen, thank you for joining us. Before I begin, I just want to mention that to find out more about your panelists, you can toggle through the Speakers tab at the top of your screen. We also encourage you to use the question and answer box on the left-hand side of your screen at any point throughout the discussion. Our panelists will endeavor to answer your questions within the allocated time. Gents, as I said, thank you so much for joining us. It's wonderful to welcome you all with us today. Rodrigo, I think I am going to hand over to you. And if I could ask if you could please just give an opening statement in terms of what are the future of distribution grids?
Hi everybody. Hi to our audience. Thank you very much, Claire, for the nice overview. Can you hear me?
Perfectly. Thank you.
Okay. So I was saying thank you very much for the nice overview, Claire. I'm having here feedback from Oliver that we are not audible. Could be? Oh, yeah. Okay. So honestly, I'm very excited to be part of this session. As a consultant in the field of energy, let's say, working the last years more closely to distribution system operators, so DSOs, from different parts of the world, I recognize that we as an industry are currently in the middle of a big transformation, yeah? A transformation that affects us all as stakeholders, including ourselves at Siemens, let's say, as technology providers. During the next hour, me and my colleagues, we would like to address some of those challenges, while pointing out also some of the strategies that we currently pursue with our partners. Yeah, I hope this could shed also some light into the discussion. With that, I would hand over to Bernd. Yeah?
Hello also, good afternoon from my side. My name is Bernd Schupffeling. I'm responsible product lifecycle manager within the distribution system organization for the topic intelligent RMU and future distribution substation. And my part will be to present you in today's webinar the hardware components of our future distribution substation. So thank you also from my side. I will hand over to Oliver now.
Hello, my name is Oliver Schrödel. Thanks a lot. I'd like to give you only the small introduction that I'm here mainly for the automation part. I'd like to show you some intelligent automation solutions for our future distribution grids. That is the part I will take place today in this webinar. And I'd like now to hand over to Rodrigo.
Yeah, okay, there was, yeah, I think from my side that's all, yeah. I think, Claire, you would like to share also some words, yeah?
Oliver, Rodrigo, if I may ask, perhaps you could start us off by explaining what exactly is driving the energy business.
Yeah, thanks. I think that's definitely a good question, and I think that the main motivation for us to be here today, addressing the topic. So, well, I think we all know that the traditional energy landscape that was once made up of a few large power plants with downstream transmission and distribution capacities is clearly undergoing a fundamental change. Yeah. The future energy world is evolving rapidly. Buildings, industries, prosumers, infrastructures, and the energy system, I would say, are starting to merge on what we would call as an integrated smart infrastructure. That smart infrastructure is, in fact, shaping the future of these grids, while it will allow connected buildings and industry in general to play a significant and more active role on this energy ecosystem. Yeah. Well, looking a bit into those drivers, as you were asking, I would basically summarize them on the 3Ds, yeah, decarbonization, decentralization, and digitalization. Yeah. Decarbonization is the ongoing push away from fossil fuels to cleaner energy sources, such as solar or wind. But it is, however, not just about reducing carbon emissions. Yeah, it's also about reducing smog and improving air quality in our cities, in our environment. With that in perspective, it's also clear that the e-mobility is becoming more and more popular and starting to be seen as an alternative to traditional means of transportation, normally more dependent on fossil fuel. Yeah. With the advent of decentralization, which is, I would say, the second pillar, more and more producers, small and medium size, I would say, will be enabled and connected to the grid, generally close to points of consumption. Yeah. So normally, generation will follow closely the consumption, the loads. Finally, and for us, a big advent, I would say, the revolution of digitalization. We believe that will enable utilities to work on a context of Industry 4.0, where all the assets are connected and data plays a crucial role on that environment, let's say. That will bring utilities into the next level, as they will be able to further optimize their processes and improve their internal operation. Yeah. Well, if we look a bit more closely into the challenges on e-mobility, for instance, which is something we are quite active currently addressing with different partners around the world, I would like to summarize mainly three aspects. Yeah. So important for us to understand that while the batteries make up a third of the cost of an electrical vehicle and the costs continue to fall as we see today, it is also expected that the demand for EVs, electrical vehicles, will rise. Yeah. So according to the latest reports, we have seen that by 2040, electric cars will draw 2.333 terawatt hours of electricity. And that has for sure an impact, yeah, in terms of energy demand. Just to give you a bit of context, that's equivalent to 10% of humanity's electricity produced in 2015. Yeah. In Germany, for instance, 2040, electrical vehicles will add 14% to the total electricity consumption. In US, around 11%, and in China, a growing market, more than 7%. Yeah. So we clearly understand the impact this should have on the system. Well, while we see that energy demand increasing in some specific areas, and here most probably, urban areas will be under huge stress, it is also important for us to understand the dynamic nature of such loads. Yeah. In that regard, for instance, we will also expect issues in terms of load imbalances, when and where the grid will be affected. That's clearly something we will have to cope with, to deal with, and load peaks, yeah, that can impact directly on the life expectancy of grid assets and existing infrastructure. So here, I would say predictive maintenance should play a very important role in that aspect as well. Yeah. Well, if we scroll down or move into the next slide, specifically on the domain of distributed generation, it's also clear for us there is a growing trend out there. Yeah, it is expected that by 2030, 50% of world's generation capacity will be assured by distributed renewables connected to the grid. So we clearly see here the ramp up of such trend and most likely the pressure that will put on the existing assets, on the existing infrastructures in order to cope with decentralized loads. Yeah. So that definitely should change the paradigm in terms of the way grids are operated today. But that's not the only aspect I would like to emphasize. Yeah. So as I was mentioning before, digitalization plays here a very important role in this aspect as well. Yeah. So here at Siemens, for instance, we are quite active with the IoT connectivity, understanding that the Internet of Things is playing a role, or is starting to play a role now. So we are moving from Industry 2.0 to Industry 4. Or 4.0. And of course, it's expected also within our industry that this trend follows also in the same way. Yeah. So as per example here for our audience, yeah, 5.5 million of new things get connected every day. Yeah. This has impacted 50 billions of assets by 2020. So just around the corner. And also interesting to understand, while we are looking to connect all these assets, again, this is an exponential growth. So more than 50% of the world's data was created last year. It's also interesting to put in perspective that less than 0.5% was analyzed and used. So we can immediately recognize the world of possibilities which is currently there, and somehow we are not taking advantage of it. Yeah. So just to give you again a bit of more context within the framework of energy or substation level, we normally understand that at SCADA level. So if we put in perspective the different architecture levels on the substation, normally on the protection relay, yeah, on the intelligent electronic devices as they are represented here, we have 100% of that information. If we go up one single level into the substation automation system or substation automation level, only roughly 15% of that data is available. Yeah, and if we go one level higher to the SCADA, then we are already working with less than 5% of the information or data which is available on the field. So we clearly see here on one side there is potential, on the other side there is a need to transform the way we are operating our systems, in the sense that we need to make this data available in order to create value out of that. Yeah, and eventually in a sense of or let's say on the current setup we currently deal with, it's definitely a constraint for us to make use of that data or to make it available for additional use.
Rodrigo, perhaps then you could give me some insight in terms of how do we cope with the energy transformation? What are the steps that we take to make this easier, more efficient? Could you give some insight there?
Mm-hmm. Yeah, thanks a lot for the question. I think let's say that generally the main ideas are sustained by these four concepts, I would say. Yeah, embrace electrification, as we have seen or as we perceive. Mobility is a reality. We will have more connected assets into the grid, being intelligent buildings, intelligent infrastructure, industries. So the grid has to be agile and ready to cope with these different assets. So definitely utilities will need to embrace electrification. Technical efficiency, I think that goes mainly in line with the automation capabilities, but also this advent of digitalization, supported mainly by the IoT engagement. As with this additional data, which is made available, let's say, for the grid operators, there is still I would say, a world of possibilities to be explored and addressed. Yeah. And again, in the same direction of embracing electrification, understanding that all these infrastructures have to be connected somehow. So it's not about reinforcing the systems on high, medium, or high voltage levels, but also medium and LV will play a very significant role in this context. And just to give you a rough example, these days we are not any longer working mainly focused on the let's say, on the advent of automation and intelligent applications for medium voltage grids, but also quite active on the LV side as well, yeah, because that's exactly where we will see the trends coming up during the next years. As additional information, I think is also interesting to share with you a bit of what we consider to be our approach, or the easiest way to approach the concept of a smart grid, yeah, supporting utilities with this energy mix transformation. So we tend to divide our approach in a grid in three main steps, I would say, yeah. The first one is mainly focused on grid monitoring, yeah. So here it's all about understanding and increasing the transparency over the grid, because again, it's clear for us that coming from generation or transmission side has been always a very reliable. We have had always a very reliable system with backup of backups, let's say, redundancies and so on. And while we go down through the grid, through these different voltage levels, it's clear for us that we somehow are losing transparency on what is going on out there. So on one first step, I think it's very important for us to increase this transparency by, again, collecting data, placing sensors, allowing measurement, current voltage values, understanding bidirectional load flows, and by doing so, also having, I would say, clarity on weak points, hotspots in the grid that somehow should require our special attention, yeah. So on one side, definitely we are focused on grid monitoring, and once we have that kind of functionality, that kind of transparency, we are in conditions to move into the next step, yeah, which would be grid control. Grid control is mainly about bringing also basic protection functionality into these lower voltage levels. And understanding also that I need some kind of telecontrol capabilities, yeah. So on one side, I'm looking to work with these utilities in the sense that we need to reinforce the topologies, the connectivity. So rather than working in pure radial grids, maybe it's wise to think about strategies to deploy also meshed capability on these different areas of the grid, creating ring topologies. And by doing so, I'm also looking to remotely control those assets on the grid, yeah. So while I'm on these two levels, I'm then, let's say, looking to reach the latest level, I would say, grid management, yeah. So mainly supported by intelligent applications. The ultimate goal here is to have a fully reliable and resilient grid working ideally without any kind of human intervention. How we put in perspective control center operation and grid monitoring or monitoring applications, well, this is exactly what I would like also to touch, because as we understand that operation always go through the control center, and normally utilities are keen to have this kind of control. That's exactly what we see here. From the control center, I can still, let's say, monitor the grid, control it, and manage it. It's also true that a new, let's say, perspective comes into place, yeah, comes into picture. That's the possibility, again, to work on this IoT world, on this digitalization process. And by doing so, I'm allowing the grid operator to start collecting data that our goal ultimately is to support with the let's say the creation of new value propositions and I would say possibilities to generate value out of that data, yeah, as I was mentioning in the beginning.
Rodrigo, thanks very much. Hand over to you, and I was wondering if you could possibly talk us through the concept of the future distribution substation. What does that encompass, and what are the possibilities with that technology?
Yeah, thank you, Claire. As already mentioned at the beginning, I will present you a little bit more in detail now the hardware, let's say like that, of the future distribution substation. In our point of view, the future distribution substation will be one of the key points in the distribution grid. And it contains the following components. So we have there installed an eco-efficient ring main unit as well as an eco-efficient distribution transformer. We have there innovative low voltage components, sensors for condition monitoring and distribution grid automation, as well as an IoT connectivity with the IEC communication standards. Having a look a little bit more in detail in our ADJ-H12 Blue GIS. So as the decarbonization topic is one of the most discussed topics around the world, we also as Siemens have started to develop a Blue GIS portfolio, which will in one day maybe replace the SF6 portfolio. The ADJ-H12 is the ring main unit up to 12 kV, which uses clean air as insulation medium and the switching technology based on the proven vacuum technology. What means customers will continue to enjoy all the benefits of the proven Siemens GIS technology, although in the future with this kind of ring main unit. So what makes this ring main unit also intelligent and digital? As we have it installed in the future distribution substation, we have the remotely controllable switch disconnectors and circuit breakers. There are installed intelligent short circuit and earth fault direction indicators, as well as a digital transformer protection device. One important aspect is the measuring of current and voltage, which is realized in our solution with so-called low power non-conventional instrument transformers for current measurement, which provide a very high accuracy for the current, and we have high accuracy also with the voltage measuring via resistive voltage dividers for the voltage measurement. And additionally, we have integrated temperature measurement in these resistive voltage dividers to give also the status evaluation for the cable connection. What means we can measure via the temperature or give a predictive information about the status of the cable connector. So as soon as the temperature is increasing, while the loads and the ambient temperatures stay stable, there is an information that something is wrong with the cable connection. So this is also installed in these ADJ-H12 Blue GIS switchgear. Having a look on the other components which are installed in the future distribution substation, we have next to our ring main unit also installed a new digital distribution transformer, the so-called Sensformer. So Sensformer is a distribution transformer, and together with its integrated sensors for oil level alarm, temperatures, and also for currents, it provides the value proposition to optimize the operation in overload situations, as well as asset protection and asset management. And all the installed sensors in these Sensformer distribution transformer are connected to a centralized gateway, which is also part of this future distribution substation and which will be explained a little bit more in detail from Oliver. So having a look on the low voltage side, because next to the medium voltage side where we have installed our ring main unit and the transformer from the medium to the low voltage side, we have also in the low voltage side of the substation installed innovative devices like intelligent ACBs and MCCBs with functionalities like status control, measurement, warnings, diagnosis, and informations to maintenance and statistics, which assists the DSO also to automate the grid. Fuse switch disconnectors with integrated fuse monitoring and tripping signal supports also for having a good asset management. As we have learned and heard from Rodrigo, e-mobility and decentralized power generation will require further selective measuring in the individual low voltage outgoing feeders. We have, last but not least, in the future distribution substation installed the so-called SEM3, what means Siemens Embedded Micrometering. This metering system to measure current and voltage for managing the volatile load situations which are caused from e-mobility or also decentralized power generation. Yeah, that was more or less my part, and I would like to give back to the moderator now.
Thank you very much, Bernd. Oliver, I'm going to hand over to you, and perhaps you could talk us through the role that intelligent grid automation plays in the future.
Perfect. Thanks a lot. So let's go to the next topic of the intelligent grid automation and also what makes a difference to our system here. And so let's start with the next slide. And let's have a look to the future distribution substation. And from my perspective, so what makes this kind of distribution substation really future-proof is the telecontrol, the integrated telecontrol, and the integrated IoT connectivity. And that not only for the medium voltage, also for the low voltage, as Bernd was also explaining and starting with these different devices which we place in the future distribution substation. Going further to the real hardware which is needed for the for this kind of installation is, and as Bernd also explained about the Blue GIS, our medium voltage switch gear, I like now to dive a little bit more in detail in the configuration of the medium voltage switchgear itself. And Bernd also mentioned about the sensors, but here in this picture now we can see really the sensors. So the voltage sensors, the voltage dividers, including the temperature sensors, which are already mentioned here, and also the current sensor, which can be also directly be integrated in the medium voltage switchgear. And what is also quite important that we are using here low power voltage transformers and also low power current transformers. So these kind of sensors fulfilling the standard IEC 61869, for example, /7 and /8. And that is a benefit is that it's really low voltage measurement, which comes with 3.25 volts, for example, for 24 kilovolts, or even for 225 millivolts for 300 amps for the current sensor. So these kind of sensors are as really low power sensors, which do not create any data and disconnecting, and you don't need to bridge these kind of connectors by removing, for example, the RTUs or the sensing equipment. So that is, first of all, something which needs to be installed in the field to get very, very detailed and precise and with a high accuracy the voltages on the different feeder base. But that is only the first part of the pillar, that was the monitoring. We like also to telecontrol the system, and for the telecontrol system we have also the motor control unit. That is the left device, this kind of a small black box, which is also integrated in the ADJ8, and it's also modular. So that means that we controlling each bay via this motor control unit, and this kind of motor control unit is connected not physically by hard wires to our SICAM A1000 RTU. No, it's communicating via protocol, via Modbus protocol, for example, which is quite simple and easy to adapt. And though this kind of flexibility is used in each and every bay, so we can immediately send direct commands to the different bays to switch on and off, and to control and to telecontrol these kind of bay. And the most important device for the supervision, for the monitoring of the sensors, is the device on the right-hand side, this kind of gray device, which is called feeder condition monitoring. So we use here a device for supervision of the different bays, are connected hardwired to the sensors, and these kind of device is able to measure precisely the current, the voltages, and can also indicate faults, overloads, earth faults, directional of earth faults, and these kind of devices, the feeder condition monitoring, which gives us quite a lot insights of the medium voltage feeder itself. All these kind of devices are later on connected via protocol to the SICAM A8000, and that is our RTU, our standard gateway to the future distribution substation. Coming a little bit more in detail to the gateway, and therefore we created a distribution automation box. That is the integrated telecontrol cubicle and IoT gateway for the system, for all components of the future distribution substations, or not even only for the medium voltage switchgear, which I discussed with you now in detail, also for the transformer, for the transformer which is integrated there, or for the components on the low voltage switchgear compartment. So that is our distribution automation box. That is a predefined cubicle which have everything integrated which is needed for a future-proof connection. And this connectivity to the different devices is done via predefined connectors and plugs. So that means this is quite easy to install, to update, and also to have always the most recent installation in place of the future distribution substation. That is quite important. The communication from these kind of device is via Modbus RTU or all other protocols inside the station, and via GPRS modem, via cellular mobile, for example, or even Ethernet to the next level of supervision. And that can be done via protocols which are coming from the IEC 60870/5 101 and 104 for the classical one, but even also more and more in future via the new protocol of IEC 61850, which takes also in future a bigger role for these kind of totally supervision of the medium voltage grid, including the primary substation above. What is also important, not only these kind of classical communication will be supported, also the new communication, like our Mainzwerk connectivity is already integrated on board these kind of cubicles and inside our RTUs. So that is also quite important that the interface to the cloud application is already integrated. And we're using there's also a standard protocol which is OPC UA PubSub for this kind of cloud connectivity. And the basic idea is that this kind of engineering is reduced to a minimum. So from the rollout perspective, this kind of box is predefined, prearranged to get hardware through the hardware connectivity, but also for the protocol connectivity to the SCADA systems or even to the cloud connectivity, though that is quite important to support all these kind of installation topics. Last topic from these kind of box, what kind of use cases we like to provide. And first of all, sure, all the monitoring topics, which was shown from the Rodrigo in the beginning, for this kind of cloud connectivity, for asset management and monitoring the stations. Next level is for remote control of the medium and low voltage components of all the components. And now coming a little bit more to the intelligent applications on top, like load management, voltage regulation, or intelligent self-healing grids and networks. That is also important to have all these kind of intelligence set up on the level, and also to support this functionality in future. And that's exactly the topic where we like to start now, with some insights of the latest style of intelligent distribution grid automation. But before starting with these kind of application, which you saw here on the screen, where you see some grids which can be automated and fully automated, also to have a little bit more insight, first of all, in the control hierarchy of the application and where to place these kind of application and what is the benefit to place it on different levels. Because from Siemens perspective, we have a full range of control hierarchy, so we can do applications on the field level, we can do applications on the control center level, but we can also do it between, and that is quite important from our perspective to find the right level and also to use all levels for intelligent distribution grid in the future. And this kind of table is an evaluation for the most relevant grid applications and where to place the automation. So, but first of all, two important vectors needs to be discussed, because the decision and the control hierarchy. So where place the decision and where to place the total control of the system. And in the first pillar of this kind of table, we see the distribution automation control hierarchy. And now I like to go not from the starting, from the top down, I like to start from the bottom line, so from the individual devices. So we can have some applications which are really placed directly in the individual devices. So really near to the process, really near to the switch gear. So imagine, for example, you have a protection relay, which is directly placed at the breaker, at the circuit breaker, and immediately the devices itself decides, okay, there is a fault on the line, and now I have to break. The next topic is that we can also have some integrated devices, so some interaction between devices. We call it smart edge devices, a group of devices, which also controls a certain amount of feeder circuits and also has the implication if there is a connectivity fault, if the energization is perfect or not. And also these kind of devices can already work together for some clever applications and do, for example, as a fast switch over between two devices in case of an overload. Then we have the secondary substation in total, where we have already some kind of internet-connected feeder circuits which can be controlled. So not only a single feeder can be monitored, also a connection, an overload of the transformer can be monitored and can do the best analysis. What is the perfect setup and what is the perfect configuration to optimize the grid efficiency? What comes now for us more and more in focus is the level of the regional control, and that is what I like to step in a little bit more, because currently we have mainly two levels, which are the control center level, where somebody is controlling it actively by an operator, or even on the protection relay side. And the regional controller takes a certain control over a certain level of region. So that means that a certain region can be optimized because of over voltages of PV plants, for example, or kinds of overloads on EVs, so electric vehicles, which can be connected, for example. And the basic idea is that these kind of centers are mainly not all over the grid, so you have some hotspots where you have problems, and that is exactly the problem which we like to solve with the regional controller. And we have the control center on top, where everything can be done, managed centrally, but the topic is also there's a lot of information in the control center, and so the decision time takes even more. So going to the arrows on the right-hand side, then you find two vectors, which goes one is up. So how much information you got, more information you have to work on, and that is hard, and the decision times is increasing. Going down to an individual device like a protection relay, you can increase or decrease the decision time to a minimum because of this kind of information which is needed for protection is quite fast. So going to this kind of regional controller, so we have integrated our applications to a self-optimizing grid, which means for certain regions we can use these kind of application and this kind of solution to optimize a certain region without, let me say, upgrading the control center, but also to have all relevant use cases and must-have use cases for grid operation, which is mainly the reduction of outage time by self-healing, the load management topic, the overload reduction, the area voltage regulation, so control the voltages on the certain region, and the automatic source transfer. So if one of the sources, one of the transformers goes out of service, that we can automatically switch over to the most healthy part. About the architecture of this kind of topic, it's quite fascinating because most of these kind of things are already installed in your grid. So you have in the primary substation, mainly these kind of substations, there's already some substation controllers inside. You have protection relays, which controls the feeder. You have transformer monitoring devices, which controls the transformer and the tap changes, for example. So you have a very, very good installed primary substation. In the field level, there is currently not so much already in, and that is the reason why we create this kind of future distribution substation, because with this kind of future distribution substation, we get all the information which we need for cable grids to do a full, complete automation. And these kind of automation can be done in the regional controller. But besides the cable grids, we can also handle overhead lines, which we have disconnectors, reclosers, and also we can handle voltage controllers and AVRs, which are placed in the grid itself. So the topic is that we have, with these kind of flexibility in the grid, we have the optimal setup to do automation of the grid itself, and also to do closed loop application. That is quite important from my perspective, and also the big change. And now let's have here this kind of setup shows simplified sketch of a medium voltage grid where we have 3 transformers on the bottom, and we have also some load capacities and some different sources, some infeeds of the feeder, for example. And now let's have a look how these kind of under voltage can be handled in an automatic way. So that means this kind of grid is supervised by a regional controller. All these kind of devices, P1 until P10 or P27, are handled by future distribution substation, which are able to switch on and off, and intelligent primary substation. And in case of an under voltage, we can figure out this in the regional controller. So the information that's on the source 4 is now under voltage. So this kind of dropping of voltage is here active in the branch with the device P25 and 24, for example, is not supplied proper, can immediately be handled by the regional controller. And there is also some kind of suggestion modus or monitoring modus available to say, okay, look, we have an under voltage on this device. We have here a kind of sequence of events which we can reuse. So please open 25 to disconnect from the unhealthy source and connect to device 5, the grid, that these kind of devices which are connected can be supplied with power and with a proper voltage level. And that is exactly what is happening here. So that means that we close the device PO5 and supply the grid in a perfect way. That is only a very, very simple schematic, which is used to the ATM schema, so the automatic source transfer schema. And with these kind of data which coming basically from the grid, we can do a lot of other applications which are more complicated, like self-healing, like voltage regulation. But the basic information which comes still from the grid are always the same. And that is the very, very intelligent topic.
Oliver, perhaps then, following on from this, I could ask you if you could expound a little bit on the benefits and the value proposition of this thought process.
Okay, thanks a lot. Yes, what are the benefits and the value proposition? So it's mainly about the grid efficiency, to make the grid more efficient, to use the assets which we have currently installed in the new future distribution substations, the cables, in the most efficient way. And that is a quite clever approach. And we have SAIDI and SAIFI, so SAIFI for the frequency, SAIDI for the duration of the outages. And we did some studies, and we have here a very, very nice figure on the left-hand side, which shows about the degree of automation. And what is quite perfect is the point 1.0 is if you don't have any automation, so you do not have any improvement. But if you go with this kind of percentage from 0 until 100%, you see that it's a fast saturation between 10 and 20% already. So that means with an automation degree of 10 until 20%, you already improve your grid about 80% in outages in the SAIDI and SAIFI. You see some different lines here for SAIDI and SAIFI, but nevertheless, you see there's a great improvement already when you start with the automation itself. And our setup of future distribution substation is exactly what we like to provide in this way, that these kind of stations needs not to be used in the entire grid, but on the important sides of the grid. And that is exactly what we see here in the next slide on the impact on the distribution grid availability and the cost benefit as an analysis. You see on the left-hand side a grid which is not automated at all. So it's only manually switched by the operator, no automation, no closed loop automation. You see here some red spots. The outage times of this kind of grid is around about 120 minutes. And after the automation of around about 15% of the station, of the important stations, of the stations, then you see here already the outage times decreased a lot. And you see in the inner circle where we have closed loop connections and where we have radial ring connectivity, that we can switch immediately in below 1 minute or even in some seconds, depending on the switching devices which we have here. And then we have some radial feeders which can be not connected at all. That is the red spots on the edge, but there is no connectivity, no additional connectivity to the other healthy sources, for example, so they stay in a row. But that means immediately you see we have a huge benefit on this. And that is one important part about this kind of cost benefit, that even with 10 until 20% of automated grid, which we have to place in the grid, because that is also something which I like to say very, very clear, you need field installation at least. You need a certain amount of this future distribution substation. Otherwise, these kind of systems will not help. So only to do some data analytics on meter data or on some asset data which are somewhere, that will not work. That will not improve in this regard to keep down the duration of interruption and the frequency of interruption. So that needs that you have telecontrol and telemeter data which you can actively use. So that's mainly my small insight about the benefits and to increase the grid efficiency.
Oliver, thank you very much. Rodrigo, I wanted to hand back to you, if I may, and still on the value proposition. Could you tell us a bit more about these findings? Can you relate some of it back to some of your project experience?
Yeah, thank you, Claire. I can take over that one, yeah. I think that's, in fact, something interesting for us, giving you a bit of context in regards of real projects where we somehow we were able, let's say, to find out the real impact of such strategies, let's say, yeah. So I just bring to your attention, for instance, an example we have had, or a project with a small DSO, a regional DSO in Germany, so-called Netze BV. They were basically, let's say, dealing with two main issues, yeah. Long feeders with long outage times And let's say by the regulation or in light of the regulation in Germany, these utilities, they are also forced to infeed from renewable in their infrastructure, yeah. So it tends to be a challenge also for them while they're, let's say, they are running with small budgets, but still they have big problems or big challenges to address as bigger DSOs, bigger companies. So I think from that perspective, we kind of put, let's say, in the table two different approaches, and I think this will be a question that will be there for many DSOs out there. On one side, what kind of strategies, let's say, to pursue in order to revamp, to retrofit the existing infrastructure, or as per alternative, let's say, finding out new methodologies, new approaches while coping with the existing infrastructure, yeah. So that was for us the challenge, while taking the assumption, a clear assumption that they would need to run with the existing infrastructure. We were looking by means of implementing automation to, let's say, to pursue a better use of that same infrastructure, yeah. So as I mentioned before, there was a need to cope with this infeed of voltage renewable. So in that regard, let's say we were also keen to start regulating voltage, because that was mainly a problem of voltage instability, yeah, extending to different sections of their feeders, medium voltage feeders. On the other side, while we were looking into the grid, and here again, as Oliver was mentioning, network studies, they play a crucial role in the way that we are developing our solutions, because as I was mentioning also at the beginning, for us it's very important to increase this transparency, or having a really good model of the grid in order to perform these simulations, because ultimately what we want also for the business case is to have a valid business case, of course, to support the business case. So what Oliver just mentioned of this idea of finding this 20% of hotspots of those areas that by integration of automation can help improving a lot the overall operation of the grid. This is exactly where these kind of studies are let's say, playing a very significant role. So we are really working closely with our teams from those departments, project department, also in that sense, yeah. So anyway, just to conclude on your answer and giving you here a bit more context. So we were basically, and again, putting in perspective the different architecture approaches, for us was clear that we would need to start addressing the issue directly from the field. So rather than looking from a top-down approach and somehow working directly on SCADA, we thought it would be more convenient and also cost-wise, let's say, more beneficial for the customer, rather place their a regional controller and having, let's say, the capability to run closed-loop automation on that specific area of the grid, yeah? So all in all, that's exactly what we see here on this picture. So on one side, we have automated roughly 11 stations from the whole universe of different stations that were there. So again, we were always looking for these 20% of stations to be automated. So as Ben was also mentioning, placing the ringman unit, all this sensor capability and so on. And by doing so, in terms of, let's say, impact, what we found out at the end of the day was that if we compare that investment against what we would call, let's say, a traditional copper investment by means of placing new copper lines, replacing the backbone of the grid, this turns out to be or to generate a saving within the range of 75%. Yeah. On the outage times, as we have seen before on the picture that Oliver was sharing, we also dramatically reduced in certain areas from 120 minutes, even lower than 20 minutes in some sections. Yeah. So let's say that at the end of the day, there is also an 80% of availability improvement with less than 15-20% of automation. So we clearly see the validation of the business case through those projects. and this is for us important while we pursue the path of automation.
Rodrigo, thank you very much. Oliver, I have a question for you. This is one that's come from the audience, and it's, is there a basic kit for remote communication?
Yes, exactly. That is exactly what our topic is in the beginning from my presentation. The basic kit is about these kind of pre-installed and predefined distribution automation box where everything is in. That is quite important, that we like to have these kind of integration which can be easy, also brought to the, let me say, retrofit station. That is exactly the topic. And depending on the customer needs, we can change communication way, for example, for GPRS communication to fiber optic communication or whatever is used specifically. But that is exactly the topic to bring down the different hardware installations to a kind of a very, very common setup which can stay as long as possible, for example, and also updated with the newest security features and all these kind of necessities which we have today for communication and security topics. Exactly. So that is one important part. One hint also, this kind of future distribution substation, also this kind of basic kit can be seen or is shown at the Siemens booth of the EUV. That is also quite important. If you have some further questions later on, please visit us at the booth, and then all these kind of things are shown there also at the fair.
Good point. Yes, Siemens will be at European Utility Week, so please do make sure that if you are there that you pop in and come and see them and learn about substation automation and the substation of the future directly from the experts. Rodrigo, I've got a question that I'm going to pose to you, and you can then hand it over to, and that is, what is the role of substation automation protocol IEC 61850 and IEC 60870 in the distribution grid?
Yeah, thanks, Claire. So I think that the role is exactly the role that has been taken so far. Yeah, so the 61850 for sure will stay as a prominent protocol, along with the 68070, 104 for sure, as it is described here on this picture, because these are exactly the kind of, I would say, functionality also that we require, specifically in the domain of smart edge communication. Yeah, so I think there was also in the past some questions how you put in perspective what is happening in Europe versus America and so on. So of course it's hard to wrap up everything in one single basket. But anyway, what we have seen as per opposition to what we have presented here, mainly focused on a cable grid, is exactly the reality we face in America, yeah, where we have a main predominance of overhead lines. And in that regard, for instance, Oliver was also touching that point in terms of the architecture. We are working a lot with fully distributed systems, yeah. So in that scenario, mainly based on smart edge communication, we are making use of goose messages, which is part of the standard of 61850, yeah. So goose message for us, it's critical in the sense that we want to communicate on peer-to-peer basis. And normally, specifically on that domain of critical infrastructure, where we really don't need, or we cannot, let's say, depend on time latencies or bandwidth to communicate with a SCADA, and then waiting for that kind of feedback. This kind of protocol is representing for us, I would say, a huge added value in the way that we are deploying this functionality. Yeah.
One important part is also that also in the IEC standard, in the new standard, also these kind of different architectures are defined. So this kind of peer-to-peer application, also the regional controller application is listed in the IEC 61850 and control center application. So it goes absolutely in the line which we're presenting here, and also Siemens is driving the IEC 61850 standard in this way. So clear statement also to Rodrigo, what Rodrigo said.
Fantastic. Thank you very much, gentlemen. And unfortunately, we have reached the end of the time that we have available for us. I'd like to thank our speakers and our audience for delivering an excellent discussion today. We hope that you've gained great value from today's webinar that will spark further discussions throughout the year. I'd like to remind you that a recording of today's webinar will be available on demand, and you can pick that up on the Smart Energy International website. For those of you attending European Utility Week next week, there is also an opportunity for you to see some of the most innovative solutions that Siemens are currently bringing to the market. A demo of the future distribution substation will be shown, along with all the other applications available at the Siemens booth. Stop by and also take the chance to discuss these topics with a pool of experts that will be there only for you. Thank you for joining.